Okay, so welcome back. Now, we start in this video talking about the perimeter, finding the length of the perimeter of the Koch snowflake. And so we're going to start by looking at the perimeter of the F sub n snowflake. Okay, and then we're going to take the limit of that. So let's go through and see what we can pick up from our investigation of what happens with the figure and the number of sides and the length of each side. Okay, so we're going to let n sub n denote the number of sides of the figure f sub n. Now, since f sub 0 is a triangle, n sub 0 is 3, because there's 3 sides. Let lowercase l sub n denote the length of each side of figure f sub n. Now, since f0 is an equilateral triangle with sides L0 equal to 1, we now need to determine N1 and L1. Okay, now, since F1, so let's say this is F0, since F1 is created by removing the middle third of each side, right? So you're removing each side and then replacing that segment, that line segment, with 2 line segments. Then that means for each side of F0, we get 4 sides in F1. Because if you remove the middle third, right, and you replace it with another equilateral triangle with 2 line segments like this, right? And now basically you've got 1, 2, 3, 4 sides now. Okay? And so what happens with that? Well, so that means N1 so therefore N1, we're replacing 3 sides, right, with 4 sides. So then N1 is equal to 3 because we start at 3 sides of the triangle, but now each side of that triangle we're replacing with 4 sides, so it's going to be 3 times 4, which equals 12. Okay, so 4 times 3. Now, since the length of each line segment is now 1/3 the length of the line segments in F0, right? Because we took the middle third, right? Which means this length here is going to be a third, and this length here is going to be a third. Because the length of the original triangle of F0 was 1. So now we know that this is a third, this is a third, so all of these are a third now. Okay? Okay. So, the length of the line segment F1 is given by this then. Right? So L1 is going to equal 1/3 of each side line. So it's going to the length 1 is going to be 1/3 of 1 right? Which is just going to be a third. Okay, now for F2, we can do the same thing similarly with F2, right? Since the middle third of each side of F1, so now this is F1, now what we're going to do is we're going to take the middle third of each side right? replace that with another equilateral triangle pointing outward. Okay, and now we get something like that, right? So for F2, since the middle third of each side of F1 is removed and replaced with 2 line segments, the number of sides is given by what? Well, again, we're replacing each side we're removing 1/3. Okay, so again, just like in N1, we've got 12, but now we're replacing each one of these 12 sides, right? We're removing the middle 1/3 of each one of these sides with 2 line segments, right? So what happens? We're going to take N1, so N2 then is equal to what? Well, just like here we had 3, which was, we could replace that with N0, right? So now N2 is going to be 4 times N1, right? Because each side we're is going to go from one side, right, is going to go to 4 sides. So each line segment, when we take out the middle third and we replace it with 2 more line segments that represents an equilateral triangle, now we're going from one side to 1, 2, 3, 4 sides. Okay, so this is going to, N1 is 4 times N0, which gives us 12, and then N2 is 4 times N1, which gives us 4 times 12, which is 48. Okay? Which, in this case here, let's write it like this. Which equals 4 squared times 3. Now, since the length of each of these sides is now 1/3 the length of the sides of F1, then we can say the length of each side of figure F2 is given by this. So L2, so the length of each side in L2 is going to be equal to 1/3 the length of L1, which equals 1/3 times 1/3 times 1, or just 1/3 squared, right? Now, more generally, since Fn is created by removing the middle third of each side of Fn minus 1 and replacing that line segment with 2 line segments of length 1/3 of L sub n minus 1 in the shape of an equilateral triangle, we know that we're going to have this in general. So based on this, we know that n sub n is going to equal what? 4, let's see here. Yeah, 4 times n sub n minus 1. Right? So that's obvious. And L sub n, the length of each side of F sub n, is going to be 1/3 L sub n minus 1. So that's obvious. Okay, so we could also write this as L sub n minus 1/3. Okay, so therefore, okay, so now we have the number of sides. So if we go here, so if we take this, so this is for figure f sub n. So now if we can go to this here using what we figured out here, then we can also write n sub n is going to equal what? Well, in terms of the final thing, because we were able to write n2 like this, right, with 2. So n sub n can be written as 4 to the nth power times 3. And L, just like we were able to do here, L sub n will equal 1/3 to the nth power. Okay, so now we're ready to represent the perimeter of f sub n. So basically, look what we have. We have the number of sides, right? The number of sides represented right here for each figure, and we have the length of each side represented for each figure. And so we can find L sub n, the perimeter of the whole figure, capital L sub n, by just multiplying these together. Okay, so let's do that. So we get L sub n equals n sub n times L sub n, which then equals 4 sub n, or 4 to the nth power times 3 over 3 to the nth power, right? And so excuse me. Let's see here. Okay, so what we can do is we can pull the 3 out, because we've got an n here and an n here. So let's pull the 3 out and put the 4/3 to the nth power. And so this represents capital L sub n, which is the perimeter of the nth figure. So therefore, the perimeter L, right? So therefore, the perimeter L, so this represents the perimeter of the nth figure. Now notice that this is in geometric form. So the length, the perimeter of the Koch snowflake equals the limit as n approaches infinity of L sub n, obviously goes to positive infinity. And that's it. So I'll come back next time and we'll look at area. See you then.